Dear distinguished guests, including lecturers, and my dear colleagues, today my presentation will be on the prevalence of antibodies against Babesia bigemina in unvaccinated animals in 3 veterinary ranges in Kurunegala district. As we all know, bovine babesiosis is a tick-borne disease caused by the epicomplexan hemoparasite of genus Babesia, and in Sri Lanka, the main causative organisms are Babesia bigemina and Babesia bovis. The disease has a huge economic impact on the dairy cattle industry as it causes milk yield losses and also fertility issues. During the acute stage, we can see clinical signs such as initial high fever, anorexia, and then the pale mucous membranes, respiratory distress, and also passing out of dark red color urine. The acute stage lasts for about 1 week and then arrives the chronic stage. In the chronic stage, we can notice a reduction in milk yield, weight losses, and then possible abortions. The diagnostic methods include taking the history and clinical signs, and at field level, the blood smears are examined under the microscope, which allows you to see inside the erythrocytes the pear-shaped organisms which are named as merozoites. And then as the treatment methods, there are 2 specific drugs used commonly as diaminosin aceturate oberonil and imidacarb dipropionate, followed by supplement therapy such as fluid therapy, iron supplements, vitamin B complexes, and also anti-inflammatory drugs. Preventive measures include the tick control, which is not feasible in Sri Lanka as we cannot eradicate the total tick populations of cattle herds. The effective preventive measure stands as the vaccination. And currently in Sri Lanka, live attenuated vaccines are used against bovine babesiosis. When we look at the background of the study, it was conducted in 3 veterinary ranges in Sri Lanka, Alauwa, Narammala and Polgahawela. The herds selected were unvaccinated and the animals belong to different age groups and both genders. And then we were trying to evaluate the immune status of the herds, and then also to identify the hotspots. That means the populations that have naive animals which are not immunologically competent. And then using these information, we were trying to enhance the effectiveness of vaccination. And then let's look at the objectives of the study. It was to detect the prevalence of antibodies against Babesia bigemina in the ranges, and then also to evaluate and compare the immune status and the herd immunity of the veterinary ranges. The materials and methods we used are as follows. Sample collection was performed at the site by restraining the animal and then surgically scabbing the venipuncture site, and using the EDTA treated tubes, 5 milliliters of blood was collected into the tubes, insulated in dry ice packs, and was transferred to the VRI laboratory. And using those samples, blood smears were prepared and stained, and they were looked under the microscope to examine the parasite morphology, and then using the samples, serum was separated by allowing a clot to form and then letting it to centrifuge, and then the supernatant was extracted as the designated serum. And then to the serum samples, ELISA was performed. Let me give you a brief idea about how ELISA works. In the ELISA plate, there are 96 wells, and the wells are coated with the antigen. And then when we add the sample, it has the antibody. The antibody and the complementary antigen will form immune complexes. And in the next step, we add the conjugate, which is linked to an enzyme. And in the next step, we add the substrate. At the presence of the enzyme, the substrate will cause these two will cause an enzymatic reaction and give a color change. This procedure was performed for the total number of samples, and then using the positive samples, a dilution series was prepared. ELISA was then repeated for the dilution series. Let me give you a brief idea about how the procedure was performed. According to the manufacturer instructions, the reagents were prepared, such as pre-dilution of the positive and negative controls, and also the serum samples. The reconstitution was HRP conjugate was done, and then the ELISA plate was designed. According to that design, the samples were loaded into the plate and incubated at 37 degrees Celsius for 30 minutes, and then the rinsing step was performed 4 times using PBS twin buffer. Then at the next step, HRP conjugate was added, incubation and rinsing was followed as in the previous step, and after that the substrate solution was added, incubation was done at room temperature for 30 minutes, and after 30 minutes the stop solution was added in the same pattern, and within 15 minutes the optical density value was read at 205 nanometers using a microplate photometer, as you can see in this image. And then the dilution series was prepared according to this image. It was a double dilution series, and the greatest dilution that gives the color change or the positive result is the antibody titer. And then when we move on to the results, in the microscopic examination, all the smears were negative for the organism. And when we perform the ELISA for the total number of samples, 8 samples gave positive results, and as a percentage it is 29.63. When we look at this table, you can see that the prevalence of antibodies is highest in Alava range and lowest in Narambala range, and all these 3 prevalences are not up to 80%. And in this bar chart you can see the percentages of positive and negative results. In this scatter plot you can see that the x-axis is the age of the animals which gave positive results, and the y-axis is the relevant and pp value. And according to this one, you can see that most of the animals that harbor a high antibody titer are young animals compared to the old animals, and also that the very old animals also harbor antibody titers. In this table you can see the red color marked boxes are the greatest dilution that gives the positive results, or in other words, it is the antibody titer of the relevant sample, and the highest antibody titer is recorded from sample number 1. That means this animal is from the Alava range, and the animal is 1 year old. You can see an image of the ELISA performed for the serial dilution. The color changes you can see. And when we move on to the discussion, as I told previously that the microscopic examination gave negative results for all the samples. That means the organism is absent in the smears, and that means that there is no ongoing infection. But when we performed ELISA for the 27 samples in total, 8 samples gave positive results. That means without vaccination, somehow they have developed an immunity, probably due to natural exposure to the organism or from passive transfer of antibodies from the dam. In all 3 veterinary ranges, there is no complete herd immunity. Prevalence of antibodies was not up to 80%. And when we looked at the scatter plot, we saw that the young animals they have relatively high antibody titers compared to the old animals, and also that with age the antibody titers doesn't go away. Old animals also have antibody titers. And in ELISA, we were able to compare the antibody titers using the dilution series. And it was concluded that in all three veterinary ranges, a pre-immune status exists without vaccination and the herd immunity developed is incomplete. So, these three ranges require vaccination. It is very important to conduct a serosurveillance prior to vaccination, because the vaccination of an already immune herd will form immune complexes, and thereby the immune herds can be made again susceptible populations, and also the cost effectiveness can be enhanced by detecting the hotspots and vaccinating them first, because during an outbreak those populations are at higher risks. I would like to thank all these people for helping me complete my study successfully, and thank you for listening to my presentation.